hello. All right, I think we're live here. What's going on? What's going on? Let's get the chat pulled up. Let's get the Discord pulled up here. All right, hello everybody. Today is Friday, January 17th, 2025. Hope you're having a wonderful day so far. Getting things loaded up here. All right. All right. Hey, 8M Speedwagon. Got the Discord notification. Awesome. Carl Bot, yes. I got that installed here. All right. Hope everyone's having a wonderful day so far. How you guys doing? Tim, welcome. How's it going? Sad the Bad, welcome in. How you guys doing? It's great to hear from you guys tonight. All right, so we are taking a stab and jump back into CS50X week 2. So we are almost done with week 2. We have to complete two more problems. We only have to complete one of the two, but for the sake of the practice, we will just do both and it'll be all right. So yeah, so let's go ahead and get started here. So this one is called Caesar. So problem to solve. Supposedly Caesar, yes, that Caesar used to encrypt, conceal in a reversible way confidential messages by shifting letters therein by some number of places. For instance, he might write A as B, B as C, C as D, and wrapping around alphabetically Z as A, and so on to say hello to someone. Caesar might write IFMMP instead of upon receiving such a message from Caesar, recipients would have to decrypt them by shifting the letters in the opposite direction by the same number of places. The secrecy of this crypto system, let me see if I can zoom in here. The secrecy of this crypto system relied on only Caesar and the recipients knowing the number of places by which Caesar had shifted his letters. Not particularly uh, secure by modern standards, but hey, if you're perhaps the first in the world to do it, pretty secure. Unencrypted text is generally called the plain text. Encrypted text is called the cipher text, and the secret is called the key. To be clear, then this is how we encrypted hello with a key of 1 yields IFMMP by shifting one letter or one index further in the alphabet, English alphabet, right? More formally, Caesar's algorithm cipher encrypts messages by rotating each letters by k positions. More formally, which is our key, right? More formally, if P is some plain text and encrypted message P at some index I is the ith character in the plain text, right? And K is a secret key, non-negative integer. Then each letter C at some index in the ciphertext is computed as, so the ciphertext letter is the current letter of P plus the key of K modulo 26 to get the remainder. Yeah, wherein modulo 26 here means remainder when dividing by 26. This formula perhaps makes the cipher seem more complicated than it is, but it's really just a concise way of expressing the algorithm precisely. Indeed, for the sake of the discussion, think A or as 0, B as 1, and H as 7, and I as 8, and Z as 25. Suppose that Caesar just wanted to say hi to someone confidentially using this time a key of 3, and so his plaintext P is high. And in this case where the plaintext first character P at index 0 is H aka 7, and his plaintext character P at index 1 is I aka 8. Right? His ciphertext character C at index 0 is thus K, big K, and his ciphertext second character, is the letter K, and his ciphertext C1 is L. Makes sense? Yes, gotcha. In a file called Caesar, in a folder called Caesar, write a program that enables you to encrypt messages using Caesar cipher. At the time the user executes the program, they should decide by providing a command line argument what the key should be in a secret message they'll provide at the runtime. we shouldn't necessarily assume that the user's key is going to be a number, though you may assume that if it is a number, it will be a positive integer. Okay, so here we go. Let's get started here. So let's go CS50.dev here. I'll get into the bad boy. Boom. Okay, let me bring this guy over here. Where'd that go? Come back. Where'd it go? Readability. There. There we go. Okay, here we go. All right, hello everybody. Thanks for coming in. Here we go. Wing Hong, welcome in. How's it going? Caesar Chavez or Caesar salad? David, hey, it's good to see you. Good to hear from you. How's it going? What's going on? General Talks, welcome. Long time no see. How you doing exactly? Oh, yes, we're close to 1,000. Thank you so much. Again, guys, we're very close to 1,000. Thank you. Truly, you guys are the backbone here of this channel, of the stream. You guys motivate me to keep coming in every day. Your interactions in the Discord, the questions you guys ask me, the positive just remarks and comments you guys have given me, saying that this has helped you in your studying and being disciplined and holding yourself accountable in whatever avenue of studying you're doing. Um, I really appreciate you guys. Nonetheless, you guys are awesome. Nevertheless, okay. So, um, specification here. Okay, let's move this up. Okay, in week 2, we need a folder called Caesar. Okay, let's go into this folder and let's add a file called Caesar.c. All right. Now let's see here. Your program should accept a single command line argument, a non-negative integer. Let's call it k for the sake of discussion. If your program is executed without any command line arguments, or with more than one command line argument, your program should print an error message of your choice with the printf and return from main a value of 1, which tends to signify an error immediately. Okay. Alright, let's try this. We have to remember the int argv stuff too. So let's go include standardIO.h. We will also include CS50.h. Okay. Let's go int main void, like so. Okay. I'm excited. Here we go. So we need to get command line arguments, right? So let me go to my notes here for CS50X that we took. So this is what we did. Int main, int argc takes in an argv like this in our main function, right? So in our main function, we're going to do int argc string argv list. Okay. So the case where if argc, so the first one, the 0, right, is the name of the program. The second or the first index provided, not the 0 index, but the second value of the first index is the key value. So it'll be a total of length of 2, right? So how did they compute that? They just said does not equal 2. Okay, directly. So you have the missing command line argument. Okay. So your program must accept a single command line argument, a non-negative integer. Let's call it k for the sake of the, okay. So if argc not equal to 2, right? If it's not equal to 2, meaning that we provide so is argc, my question is it 0 indexed really? If argc, hey, how's it going? Welcome in, Subu or Sabu. I appreciate you coming in. Welcome. Awesome. It's good to hear from you. Print hello with a string of argv index 1. Because index 0 is the, and if it's not 2, for how many are in the argv given. Okay, so if it's not 2, argument count. So we need 1. Argument count would be 1. Because we don't want 2 argument counts. We want 1 argument count. So where do they capture? So argv at index 1 is the argument given. Printf. Usage. Right, like so. So now in argv, in our string, in our list of argv, we want to access. My question is, in int argc string argv, does the call to initialize the program count as the 0 index argv? Yes, in the main function declaration, int main int argv string argv, the arg0 element is the array and the represents the name of the program that is invoked. And then if the program is named my program, it runs my program, then argv will contain / my program. If the program is like executed with a path, okay, got you. So we need to access argv1. So key is equal to, we'll call int key is equal to if if argv at index 1 is, we need to declare it an integer here, right? Because it's a string inside of here. if int argv index 1 is less than, it needs to be a non-negative integer less than 0. So then we'll say here, actually we'll say, or if we'll say this here, right? Your program should print an error message with your choice and return a main function with a value of 1. So then here we will return 1, right? If any characters in the command line argument is not a decimal digit, your program should print the message usage key in. It's not a decimal digit. Hey, Sticky Steve. I'm not sure if this is just for content or not, but I'm happy you're learning for the sake of learning. Yeah, awesome. I appreciate. Thank you so much for the comment. You're great. Yeah, we're just learning for fun here. I have a job, as a chemist, and I just enjoy computer science, and so I'm just doing this for fun. And if anybody else is out there trying to learn this as well, I thought I would, stream it to help out anybody else. If anybody else has kind of learned in it, as long as kind of with me or in their own pace, and just wanting, camaraderie or whatever. So, if any of the characters the command line argument is not a decimal digit, your program should. Okay, so then we need to go ASCII table. Let's back it up here. So a decimal digit so if the count is not 1, so the arg count needs to be 2 though, because the first arg count is going to be, right, the name of the program. So numbers, so how do we determine if it is an integer or not, or if it, yeah, an integer or not? How do we make sure that the int argv is an integer? Obviously, if it's less than 0, if we try to int argv, we declared int argv1 as an integer. And then we check if it's less than 0. And so then if it is, we print this message and return 1. Okay. So then, do not assume that k will be less than or equal to 26. Your program should work for all non-negative integral values of k less than this. In other words, you don't need to worry about your program eventually breaks. You consider value. Okay. Alphabetical, but even if k is greater than 26, Alphabetic characters in your program's input should remain alphabetic characters in your program's output. For instance, if K is 27, A should not become backslash, even though backslash is 27 positions away from A in ASCII. A should become B since B is 27 positions away from A, provided you wrap from A to Z to A. Your program should output plain text with 2 spaces but without a new line, and then prompt the user for a string of plain text. Okay, so your program must output plain text with 2 spaces but without a new line, and then prompt the user for a string. Okay, so then we'll say we'll call a function here, or we'll just say plain text is equal to, this is going to be a string, plain text is equal to get string, which will be plain text like that with 2 spaces. Okay. Plain text, 2 spaces. Yeah, okay. So we get plain text. And then your program must output cipher text with 1 space but without a new line, followed by the plain text corresponding cipher text. Which is rotated K positions, non-alphabet characters to be outputted unchanged. Your program must preserve case, capital letters, though rotated must remain capitalized letters. Lowercase must remain lowercase. After outputting ciphertext, you should print a new line. Your program should exit by returning 0 from main. Okay, so we need to call Caesar convert on plain text with a key given, right? How is your Python coming along? I like to see you work on a project if you have any time. Yeah, I work on my Python projects almost every stream. So I have the small business manager that we've been working on live on stream here, which has really been a cool project. Really quickly, not to kind of deviate from this, but we have our main function. We have a lot of functions here in our main program, like menu hopping basically, and managing small businesses and items and things like that. We can get into that later if you want. After this. Okay, so we're going to call Caesar convert with plain text and key. Okay, we need to define this function. So, string Caesar convert. It's going to take in some plain text, right, in the form of a string, and then also a integer, which is a key, right? Inside this function, we need to have We need to loop through every value of the plain text. We need to identify if that value is in the range of 65 to 90 or 97 to 122. So we could say is alpha, right? We could just use the is alpha again. So we could say for I equals to 0, the string length of plain text, right, is greater than I, while str length greater than I, pretty much, we're going to continually increase I one time. And what are we going to do during this iteration over every single value in our plain text? Well, we are going to say current char, right, is going to be defined by a char is equal to the plain text at index value I that we're currently on, right? We're going to say if is alpha on current char, right? If it isn't alpha, we want to add the key value to it. New encrypted char, right? Encrypted char is equal to encrypted char is equal to current char plus the key provided, right? We also need to have a new string, encrypted string is equal to a blank string, right? And we'll call this string after we, no, comma there. So after we call encrypted char, we need to add the char. Hey Tanmay, how's it going? Welcome in. It's awesome to hear from you. How you doing? What's new with you? It's been a minute. How's it going? If you guys are enjoying the stream so far, please follow along. I really enjoy you guys being here with me, and if you guys are also enjoying, maybe throw it a like. It really helps YouTube keep promoting it, and we've been getting into the algorithm here, which has been really, really awesome. So thank you guys so much. Okay. So we have the encrypted char plus the key. We then need to take this encrypted char and add it to the encrypted string. So encrypted string plus equals encrypted char. Hey Ryan, welcome back. It's awesome to hear from you. Welcome back. Keeping the streak alive here. So we add the encrypted char to the encrypted string. This probably needs to be plus equals. Brian, welcome. Everybody's rolling in right now. The whole gang's rolling up. You guys are awesome. Welcome in. Welcome back, everybody. Um, Great. So we have that. So we check if it's alpha. If it is an alpha, we have an encrypted char definition. We take the current char that we're on that was determined alpha, and we add the key value to it. Um, we then, uh, hey Bristol, welcome back. Like I said, everybody's rolling in right now. Awesome. Appreciate you guys being here. Welcome. So then we're just going to add the encrypted char onto the encrypted string. Um, Else, right? Else, if it's not an alphanumeric character, it's either a number or um, like a sorry punctuation, whatever. So we'll just go ahead and say else. Encrypted string plus equals current char. Right, we're going to add the current char to the encrypted string. So that will successfully, and then once the for loop is completely finished, we will return the encrypted string, right? Now, is that everything it wants us to do to it? Is to just... Now we need to handle the wrapping though, right? So we need to happen the wrapping at the key change here, right? So what can we do here? So we can say... So we need to have that modulo 26 here, right, as well, to get the remainder. Where was that formula at? Here. So we have plus key. Modulo 26. So this will take the current char. So let's say that the current char is A at 65. And we add the key of a key value of 1 to get B. Well, we modulo that by 26. So that's 65 plus 60. $131. Oh no, sorry. Current char 65 plus 1 would be 66 divided by 26 would give us a remainder of 0.538, right? Or no, so it wouldn't be a point, so it'd be 26 can go into it 2 times evenly. So we have to handle the wrapping here. How can we do this? So if our key is 1, we're shifting A to B, right? Well then, if we divide modulo by 26 here, I gotta set up for this. Here we go. Okay, so let me pull up here. Let me just make make it like this. test equals 65 plus 1, right? Modulo 26. Okay. 14 is the remainder. Okay. Right. So what do we need to do with that 14? If you go beyond, right? If the current encrypted char is no longer alpha, right? Because if you add the key, let's say we remove this. If you add the key to it, right? Let's say that you're on Z at 90. Let's say you added 1, so that would give you right or left hand bracket. Well, no, we want to go wrap back to A here. So we would have 90 plus 1 modulo 26 in my Python file is 95 plus 1 modulo 26, 18, or sorry, 90, my bad. $13, right? So that gives us 13 left over, going from 90. To wrap back to 65. So what does that 13 tell us? Because that would give us 90 plus 13, 103 at G. Little G. Key is 1. Yeah, Tim, I'm locked in here for sure. So why? So obviously 91, 26 goes in there twice and you have 13 left over. So why don't we just do the addition to key, or to the encrypted char? We evaluate if that encrypted char is alpha. If it is not, we reduce the value by 26. Right? Because if we do 91 minus 26, that brings us back to 65. So let's just do this. Let's do the key addition. We'll say if encrypted char is alpha, right? If the encrypted char is currently alphabetic in alpha, right? Like so. So if the current one is alpha after we have moved it forward in our key. But what happens? No, that won't work though, because let's say that the key is large enough to just be within this determination of alphabeticals. So 65 is our 0. So we wouldn't want to do that then. Shoot. So if we don't want to do that, we go back to that modulo approach, right? When P0 is H, aka 7 is plain text characters, P1 is I, aka 8. A cipher text is thus K and L. Why with the modulo 26 though? So if we determine that it is an alphabetical, okay, so we'll just do this evaluation. We'll do this then. If encrypted char right is less than or is greater than 95, or encrypted char is greater than 122, right? If we shift up past the bounds of the uppercase and lowercase limits on our ASCII table, right? Encrypted char plus minus equals 26. Right, so if we start on 90 and we go up to 91 with a key of 1, right? Oop, we're past 90 here. So this encrypted char is greater than 90, so we need to reduce it down by 26 to wrap. And then, yeah, okay. So then same here is if this goes no, but this won't work really either. What if it's so large that the 26 doesn't cover it? We're going to have an array of the alphabet, basically. Right? Is that what's needed here? But so if I'm at 90, which I'm at Z, big Z, and I add 1 to it, I'm at 91. My modulo is 13. I have a remainder of 13. What does that tell us? I mean, 13 is this carriage return. You can add, it doesn't really do much. I mean, do we need to also... So we... So we need to get a loop over 26 values and compute that down so if we say for I in the 26, right, 26 less than I or greater than I plus plus, that'll do 26 loops, 26 for loops, right? We can evaluate, and I will be the index values 0 through 25. We can then say so if it's alpha, right, if the character that we're currently on is alphabetical, for I equals 0, 26 greater than I plus plus, right? No, we don't want to do something 26 times. We need to well, let's just first try to wrap. Okay, hold on. So 65 is our baseline actually. If we wrap, we know a difference between the endpoint and where we wrap to, right? So rather than saying this, if it's currently an alpha, right, we're going to say char is a new char is equal to current char, or we'll say shifted char is equal to current char plus the key, right? If the current char, if the shifted char so if it was alphabetical, right, which means it was within the bounds of 65 and 90 and 90 and 97 and 122, The only thing is if we add a key of like 10 from to 90, we'll end up at 100, which is lowercase d. So we don't want to determine if it is alpha. We want to determine if after we do the shift, if we have increased past 90 or 122. Because at that point, it doesn't matter if we have bled into this. We know that we have gone past our original bound for that one character, and we need to wrap it. So the shifted char, if shifted char is greater than 90 or shifted char is greater than 122, right? If it's greater than 90 or greater than 122, no, because what happens if you have to wrap multiple times? Hmm. So we need to get the index value. So this, no, this wouldn't work either. So we need to get the index value by reducing it down by 65. That would give us the equivalent of what it would be in the range of 0 to 26, or 0 to 25, right? Yeah. So if it is an alpha, I don't know, Lo, I don't know. I keep getting down some dead ends here. So the thing is it gives us this formula, right? Of the current character, the cipher character is the current plain text character plus the key modulo by 26. But I don't get this. So like, oh, this is in a range of 0 to 26. Okay, so sorry. So what we have to do then is say, um, so, so we modulo 26. So we have to, we're doing that, right? I was moduloing the ASCII values, and that's not correct. I need to reduce the ASCII value down to a 26, down to a factor of, or a value of in between 26. So we'll just say, so the encrypted chart plus the key um, minus 65, right? Plus the key. So that'll take, let's say that it is 90, right? Our character is Z at 90. That'll take 65 from the character to give us 25, which will be the last index value of a character. So then, which will give us modulo 26 plus key modulo 26. So now, okay, so if current char is, let's say, 90, bit capital Z, that'll take 65, giving us an index value an index value of an array in our mind, appropriate aligned with index 0 to 20 to 25 for every value in the alphabet, right? Where 0 is just our starting place. So if we modulo 26, giving us 25, right? So if this is 25 plus our key of 1, 26, that would give us a key of 0. Modulo 26 would give us 0 for the encrypted char. We just need to go and then add back to this 65. Right? So we take the current character that we're on. We take 65 away from it to proportionally reduce it down to its base level of 0 to 25 for an index of a size of an alphabet, right? We then add to it the key, right? And we modulo 26 to get the remainder. What I was doing earlier was I was modulating the values from the decimals right here, right? The actual value associated with ASCII, and that's why I was getting that 13. I was doing 91 modulo 26, and I was getting 13, and it wasn't making sense. But now, because we needed to get it onto the level of 0 to 20 or 26 values, of 0 to 25 inclusive. So now this will, in the case of our 90 example of capital Z, 90 gets placed here. 65 reduces that down to 25. We add, let's say our key is 1, we're shifting it to 1 unit or 1 index value. So key increases it by 1. That makes our new value 26. We modulo that by 26, and that gives us a remainder of 0. Well, that is, right, because that corresponds to A. That wraps to A. And then we add 65 of it to get A, right? And we declare that as a char. And so now what we need to do is encrypted string plus equals encrypted char. Right? Else, if it's not an alphabetical character, we can just add it to our encrypted string, and we can return the encrypted string at the end of this. So I think that'll work. Your program must output cipher text with one space but without a new line. Okay, so let's go back up here. Oh, cool. Tim A looks like he had the same strategy as me. Nice. Cool. We're on the right track here, it sounds like. Okay, so now we come back up here, right? We have Caesar cipher with plain text and key, and this returns a encrypted text, right? So encrypted string is equal to this, which this is going to be a string. We need to take this guy, paste it up here, right, as our precursor. Um, right, so encrypted string here returns the encrypted string. Must output, so print f with the percent string, encrypted string, right? Like so. And then with one space. So print cipher text. Like that. So should we test this? And should print a new line. After outputting ciphertext, your program should print a new line. Exit by returning 0 from main. Okay. All right. Hopefully you guys are doing well. Let's try this out. Probably have bugs here, but we'll find them as they come. Open integrated terminal. We will make Caesar. Expected expression. Error, expected expression. Oh, okay. Wait, what? Expected expression? What is the little window thing saying? I can't even make though? Error, expected expression. Too many errors omitted, stopping now. Is this supposed to be string? Yeah, string not int on argv. Okay. So here, this is a string. Well, what happens if I just put string here then? I don't think that'll work. Oh, so do we have to make this just int? Our argv's are integers, our arguments given was an integer. what's going on here? Second parameter of, quote, main argument array must be type, quote, char. Second parameter of main. So we have to, if we leave string here, so we'll say because we're calling key here and we're not providing a key anywhere also. So that's why. In argv1. If key, like that. Incompatible pointer to integer conversion, initializing int with an expression of type string. So do I have to do this ASCII table thing? Is if it's a, right? If they provide a key value, oh no, well, it should just be argv0, right, is the name of the program. argv1 is the argument. So how do I convert a string to an integer then? Without just calling an int do I have to cast this like so? Like we did last time? Cast a smaller integer type int with a string. That's what I'm doing here. Convert an argv1 to an int. It's a library function. CS50X functions. That's right. Get double. Print, scan, close file, read, write, printf, scanf, standard library, random, string caster, compares two strings, seal, convert char to uppercase to lowercase, is digit. Convert character ASCII to uppercase to lowercase. Convert string to an integer. ATOI. This converts a positive or negative integer from a string into, okay. Oh yeah, standard library ATOI. Okay, so we'll include standard library.h. We will take a toy. But this is just a character though. Or I guess it's a string. Like that. Unexpected name string expression, okay. So remove that. Okay, we need a thing here. Encrypted string. Oh shoot. Encrypted string like that. Okay. Identify declare I. Okay, yeah, it's gotta be int here. Start length. String 8.h header. Right. Let's keep going here. Okay. We need the C type. Okay, we made it there. Okay, here we go. / Caesar. Hello. Ah, that didn't work. Haha. Let's just give it a see what I turns to. Didn't even work. Well, so we're converting argv to so what happens if I make this I get hello again? usage. Okay, right? Like that. So I can only give 2 command line arguments. Perfect. So that part is working. Now what it's doing is it's hello. Is it trying to hmm. So we're not even getting the ciphertext to output either. Ciphertext with the string. So we had that. Is digit. How can I say like not? Like, so I say is digit for argv index 1. How can I say not is can you preface it with an exclamation mark to say not is digit like this? Or like not equal is digit like this? Or like do you just say like that? So now if we make argv cast a small integer type in from string. Okay, so we have to keep the key integer conversion up top. Remove it here. Place key here. Okay, cool. That worked. So now we'll go back. We'll put -1. We'll put 1 here. So now we're getting it for everything. So now it's giving us the usage for any input. I'm just going to do this temporarily for right now. I'm going to say print f percent %I percent %I our key, right? Like that. Okay, so it is detecting key. If not, digit. So why are we getting this? Key is evaluating to not a digit. Why? So the is digit key printf. I don't think that this not is working because what? If the arg count is not equal to 2, yeah, like that. If is bool? %B? How do you print a bool? Maybe is digit only works if it's a single character? Oh, yeah. Look at that. So our key is our argv, which is currently a string. So if I print f percent, right? So it is taking key as int, right? So it's successfully converting key to integer. So now I just need to say, if it's argc is not 2, right? Or key is less than 0, or right, if it's not even yeah, Nash, which is the best way to learn coding? Watching videos or reading books? I really like reading books personally. Yeah, Dinesh, if you're just starting, I would highly recommend taking a peek at Python Crash Course for a beginner. It's a great, introductory book for Python. I would pair this with Harvard CS50P. Those in tandem will help you, propel forward into programming and getting the basics and understandings using some simple examples and doing some simple practice problems. So I have a copy of this provided in my Discord linked below for free. So if you wanted to get access to like a roadmap of all my study resources that I've been using as a beginner personally, I've only been coding for about 6-7 months now after my 9 to 5 job as a chemist. So I highly recommend Python Crash Course. Key does not equal 0. Might as well be 26 at that point. What? Key does not equal 0? We could do that. That's a good idea, Jaws. Loop through the string key. Okay. So let's do int um, is digit on some value of string stir, right? And say for I equals 0, Sterling of stir I plus plus, right? If stir at index I is digit, right? If the stir at index I is a digit, we need to like that. Okay, if it is a digit, if not is digit at stir index I, turn false. It's like that. So if we want to check if every value is a digit, we need bool.h. Is it bool.h? I forgot. Okay. So I check if it's a digit. So we convert it to an integer. So the thing is if I percent I key. Okay. 0. So if you try to convert a word into an int, you get a 0 for false, meaning that this key value was okay, so but the thing is though is if we wanted to use literally 0, now what happens if I say string here? New compatible integer point conversion on a string. Okay. So it doesn't like in here it returns to an integer. So that's why you have to keep it as in. So if this turns out to be false, it'll fill in 0 for this value. But if it is 0 at this point, right, that won't, I can't say if it is 0 to do this because then you can't run on a 0 input, like if they actually gave a 0. Or is it or is the 0 that is given here different from a 0 that would be given from an actual conversion from string quote 0 to 0? So yeah, it defaults to 0. Thanks, yeah, like Jaws said. If given a non, like we figured out here, right? Hmm. So we convert it to an integer. We wouldn't necessarily want to convert it to an integer or do this evaluation quite yet. Let's get rid of this. So return false. So how can I return false? What do I have to use to return false though? I don't know if false will, how do you return? He didn't show. So that's the problem with some of these lectures is they don't show you like these other, they give you like they give you the library, the manual pages, right? But it's kind of, I think, unfair to like require some arbitrary function in a list of a bunch of manual pages that I don't know. If I was a student in this class that I paid for it, I'd be kind of meh. I mean, yeah, it helps you learn, but really, is it the most efficient way of learning? Like struggling through with like if you didn't know to look in these documents, I don't know. There's a, cost to it. So you just lowercase false then like that. we'll do this so we save time here. So then we'll say, we'll do the evaluation on this after we determine if it is a digit or not. So string is equal to, or actually more, it'd be bool. Arg is, key is digit, right? And then we would say is digit function that I wrote for the arg v index of 1. Okay. So we give a bool here. We say, well, int the conversion here. Not here. We need to do the evaluation first. And then int the current, int it down here. Like that. And this has to return a boolean because I made it a bool up front here. Okay, so we have bool is digit, which is a stir string, right? For int I equals 0, we take the stir length of the stir given is equal to n, and we evaluate while n is greater than I plus plus. If we evaluate is digit for that certain character at index I on the string, we're going to return false if it's not, right? That will return false to here if that is not true. If that is false in here, not true, then we'll give this message here. And we'll take this guy, bring it out front here, like so. Okay. Yeah, we have to assign the n on this side, right? All right, let's try this out. So we're getting undeclared key. Key here, right? So if we convert it to a digit, So I guess we'd have to keep the key up front, right? All right, we need to set using result assignment as a condition without parentheses. Place parentheses around the assignment. Used to turn the assignment into an equal comparison expression. So we have to parenthesis around this. But I want just n to equal. I don't want to do a comparison. Into an inequality comparison. Have undefined n. So I need to provide an n here. Like so. Which will be an int as well. Ooh. Clear. Expected expression equals 0. Expected expression int n equals 0. Too many errors a minute. Expected expression for int I equals 0. N equals Bernoulli's true. I feel like that's what I had before. Oh, but you have to have I before it. Because it was declared before. I feel like that's exactly what I had before. You have the I out front. Oh. Oh, here she comes. Because you have an assignment of the variable, like so there. Makes it easier. 64. Non-void. Function of return a value all in control path. Non-void function. A non-void function does not return a value. Return false, else return true. Right, not return true. We don't want to return true at the here. We want to return at the end of it. Like that. So now if we make no. Oh, that's still inside the for loop. Like that. Oh, not mail. Get out of here. There we go. Okay, let's try it out here. Caesar hello will give us the error. Caesar 0 give us plain text AAA. Doesn't output any cipher text, so that part's broken. If I go Caesar -1, I get the usage. If I go Caesar 95 AAA. Whoa, what happened here? Question mark cipher C. That's funny. AAA. Whoa. All right. So, we got some weird things going on with our here. What is going on here? What happens if I give capitals? Nothing. Okay, let's see what's going on here. So I guess we could do the same thing we did before here. N equals that. That's an I. String plain text given. We call convert with the key on the plain text. Take encrypted text. So what happens if I run this and give an exclamation point? It doesn't even return those. Okay. So if I give exclamation points, else encrypted string plus current char. Well, we're adding an integer key. Which I guess expresses yeah, I was thinking that too. SS low, right? Especially if you're doing other classes, right? You know. So it's obviously not appropriately doing something here. So we take in the plain text and a key. We have an encrypted string is equal to this. And then it got printed with an and sign afterwards. Why did it print with an and sign afterwards? What? It printed 2 extra keys. Hmm. Debugger time? Yeah. Um, I kind of want to see what's going on with this encrypted char at each iteration. So I set a point here and go debug and debug. What happened? Uh, hmm. So we're looping over every value in the plain text, right? We are going to save the current char that we're looping in as the plain text index I. If that current char is an alphanumeric character, oh, is it giving us these 2 spaces as characters? No, it wouldn't do that. It would return nothing in the parentheses. Maybe we can't add chars to strings. Maybe we need to add a char to a char. No, but I don't think that'll work either. Yeah. because I don't need a space there. Empty string. Does this have to be of type string as well in order to concatenate to a string? No, because it's accessing an individual character in a string. Yeah, the cipher does not apply to digits. So that's why I have this alpha check here. And we're only doing the wrapping and stuff if it's an alpha. So let's go ahead and print f percent c encrypted char. Right? ABC. HIJ. Nope. What? So my key is an int. Let me see. All right. So if we call Caesar for 5, I take ABC. Let me call this \n. Caesar 0. ABC should just give me ABC back. What is going on? Why is he giving me all these funky characters? I just finished chapter 1 and 2 of Python Crash Course. Thank you for the recommendation. Made way more clear. Awesome, dude. I appreciate that's so cool. What did you enjoy about it? Um, did you try any of like the practice problems and stuff? What did you if you could give your testimony, that let us hear it. What do you guys what do you think? Yeah, right. So that's what I was thinking. Like we're affecting the character values somewhere. And so it's got to be here. So what if I take this here and go here? Print encrypted char. Or no, hold on. Let's take this back actually. Put it here, and this is encrypted string. And this should be S here. Make ABC. What the heck is going on? Caesar 5, ABC, exclamation point 2 3. Yeah, it's looping 3 times, right? So then what happens if I take this and instead print the encrypted string here before let's go ahead and take it and print it here before we return it. ABC. Did it do it really fast? Did I just not see it? Because it returned and closed this. Hmm. I was doing CS50P, but after the first video, I couldn't do the problem since it was too fast paced for me. Yeah, I felt that way as well. They really don't do a good job prefacing things like the escape characters. Like I didn't even realize what the \n was and what it truly did until like halfway through the course. So it is a good course, but it does have its flaws in my opinion. So sometimes we're not even returning values. So can we not? I think it's happening on this concatenation of type char and type string. Can we not convert? Now, what if I kept these as strings, right? Can I do that? Can I set this as a string? Can I just set these as strings and then just combine them together rather than being chars? The encrypted string is return a string because you return a string. I don't think it'll let us. Yeah, right. So we need to convert. I think that's what's happening though, is that we're trying to take the char and add it to a string. So current char minus 65 would take us plus the key value. I mean, I could throw the 65 out front here, but it wouldn't really change anything in terms of operations. No, nothing. So if I press Caesar 1, ABC, then we get the funkiness. So I get the print encrypted string. Okay, so it is happening in this section here. So we know where it's going wrong. Okay. And we don't need this print then. So we have a string, encrypted string. We then loop over, getting the index value of every place in the plain text attribute or parameter given. We single out every character in the plain text at that index. If the current char is alpha, what I'm going to do here is make sure it's reading our ABC. So we'll go here and say printf %c current char. All right. So that's going to print out every char now. So let's see what happens. We get ABC. Okay, good. So it's detecting that it is alphanumeric. It is alphabetical. Okay. So then we're taking the encrypted char. So let me take this here, Command X, here, take this, print this for the encrypted char. Make ABC. And now we're getting HIJ. So if it's going up by 1, it should be BCD, right? Not HIJ capitals. So clear, the math operation here is not correct. So we have our ASCII table. Let's say that we're on option 90, like we did earlier. Z at option 90. ASCII value 90. If we're on this value, we're going to subtract it by 65 to get to its value associated with an index of 0 to 25 inclusive. So 90 minus 25, or sorry, minus 65 gives us 25. If our key is 1, this total expression gives us 26. We modulo that down to give us 0, right? This expression will then give us 0. And then we add 65 back to that to get back to char A, which is the wraparound. So let's do it for A then. If I put in 65, 65 gets reduced to 0. I add the key of 1 plus 1. Well, 1 modulo 26 is 0. Plus 65 would give me no, sorry. 1 modulo 26 gives me, what does that give you? 1. And so then you add 65 to it to get to 66. So my math operation, I feel like, is correct. Let's just do the operation like one at a time. Char, encrypted char is equal to current char minus 65 plus the key value modulo 26 Oh, my stream is really lagging here. My stream is like not losing connection. Sorry about that, guys. My stream just like lost all connection. It's still coming in and out. How is it for you? Can you try to watch it? The stream. Okay, it's all right. It's not too bad. Okay, I think we're back. I think we're good here. So let's see what happens if we just reduce it by 65. Okay, let's see what happens. What happens if we just reduce it by 65? You get a blank space, exclamation point, and that. Yeah, so 0. Perfect. Where is my mouse? Oh, I think my mouse died. Oh, yeah, it did. Shoot. Oh, that sucks really bad. Apple Magic Mouse can't charge it while it's working, while it's going. I'll have to use my trackpad here. Okay, I'll try. Here we go. I'm using my trackpad on my laptop here. My mouse died. The Apple Magic Mouse. Oh, death of me here. Okay. Okay, so now let's go like this. Char encrypted char is equal to current or encrypted char or plus equal key, right? So now let's see what happens. Make Caesar. Invalid plus equal at the end of the declaration. Did you mean equal? Yeah, that's what we're doing here, Ryan. We're printing the chars as we're, yeah. Oh yeah, it has to be or 97 if it's lowercase. Hmm. That's right. if it's alpha, if current char, if 65 less than or equal to current char, and current char less than or equal to 90, we're going to do these. Oh, this mouse pad is going to be rough. And we'll say if, we'll copy this here. Here, this will say else if between 197 and 122, right? Like that. We'll take this guy here, paste it here, here. And then okay, so yeah. Minus 65. Plus key. We don't need to define this here. It's already been defined. The encrypted char is equal to so once we add the key to it, we take the modulo. Modulo 26. And then we'll say this again. Encrypted chars, right? Plus 65. So I'm going to do this. And see what it would be like. I'm going to take these values here. Control C. Put them up here. Enter. I'm going to say instead of 65, it's going to be 97. 97. Okay. Make Caesar of, let's do Caesar 0 first. ABC. ABC ciphered. Okay, perfect. That one worked. Now if we give of 1, ABC, BCD. Okay, perfect. So it just didn't like that order of operations on our math operation. So, but by just defining it in each line, it liked that, so whatever. Whatever. We had the process right, it just didn't like our operations apparently. I'm not sure how it handles the modulo in terms of PEMDAS, but um, yeah. Okay, so now it's working appropriately. At least for printing the characters, right? So now we need to solve the issue of trying to take a string, encrypted string, and add to it these characters. We need to convert the characters to a string. Convert a char to uppercase or lowercase. Convert string to int, string to float, string to long. Convert values. Convert character to ASCII. Convert string to integer. Convert a floating point. Convert a floating point string, string, string. Convert a wide character string. No. Convert a multi-byte. Convert a string. Convert a wide character to uppercase. So what happens if you just concatenate chars together? Right? What if I made this a char with a space? Hmm. Yeah, we can clean it up later, Lo. We're just trying to solve the problem for right now. Argenis, welcome. Sorry. Yeah, I'm we're learning C right now and is the in we're doing the CS50X course right now. So right now we need to handle this. So could we add every character to an array? No, like what could we do? Convert to lower. We need to we're converting the char and now we need to put those chars together into a string. How do we concatenate chars into strings? Hmm. It's a string class implemented as an array. No, I don't think so. I don't think so. Like, you can't take the length of... You can take the length of string, actually, and index into it. So, yeah, I guess. Right. I mean, should I just declare this a stir? But I thought you can't index into an individual character of a string with a stir declaration. And is alpha checks a character? Character classification function. Okay, so if we have an encrypted string that's blank, and we set the encrypted string is equal to, that's a good idea, SS though. I always forget that you can set the actual index I. Like that, right? So you can set the index of I that you're currently on, right, to this. Yeah, I like that. That's a good idea. Like that. Okay, so now if I clear this, makes user encrypted char. Here. Or not encrypted char, current char. No, I need to reverse this. We want to set that placeholder as the encrypted char. Like so. Encrypted char. And then this is going to be current char down here. Like that, right? So now if I go here, go make Caesar 0, ABC. Oh. What happened there? I've never gotten that error before. Caesar 0, ABC, all caps. Core dumped. What does that mean? So we'll set the encrypted string index I is equal to the encrypted char. Segmentation fault, core dumped. I have no idea what that means. off by 1 error. Let's see here. CS50 manual pages. String H. Oops. Well, let me click on that. Locate the length, calculate the length of a substring, copy a string, compare, locate substring. Okay, so then should we have an encrypted string be a char array? Like so. Return char. A char array. So if we return it into a char array, encrypted string gets type char. So it would have to be so if plain text is 5, this array would have to be the stir length, the plain text, plus 1, right? So that returns the encrypted string. Yeah, the nullity, got you, Jaws. Char does not equal char. So now we have char being returned here as an array of the converted values. We then need to loop through this char and access every value inside of it. And print it. So we'll say for I equals 0, n equals the stir length of encrypted string. That's not a stir, it's an array. But it'd be a length of plain text. Right? I or n is greater than I plus plus, and then we'll say print ciphertext of a char for encrypted string index I. So this would be encrypted array rather, right? And then it wants us to print like a new line. But this is going to print ciphertext over and over again. So we need to print the ciphertext above the for loop. Cipher text 1, like that, and then print the character like that. Gotta use char or const char. So if we can't return an array, so I'll just take this, Command X, get rid of it, get rid of this, call that, and do this. It's got to go in our for loop. Int I, int n. What did I say earlier? Oh, okay. New line. A non-void function does not return a value. So this has to be void. Void. C00, ABC, ABC, 0, ABC, ABC, 1, ABC, BCD, come on! Here we go. We're getting it. Okay, come on! Come on! Come on! We're almost there. Man, I've been working on this for too long. Oh my gosh. This is a lot harder of a problem than I thought. I mean, it's not that hard, but it's just like there's just so many like angles that you gotta like they keep asking you for. Yeah, so rather than returning any values, right, to main, right? Because we're kind of bound by a lot of the stuff that is talked about in lecture. We can't like declare const stuff, and I mean we've talked about const a little bit, but just not to the detail we need to like be able to return like arrays and all that crap. So uh, I just handled the print directly inside of this Caesar convert and then just had it called in the main function. So nothing is returned. The print just happens in that function. So which is fine, I guess. It really doesn't matter. Um, right. So what else do we need? So if I type go, if I do Caesar, let's do these examples that it wants. 1, 2, 3 gives us Caesar key usage. Caesar 1 gives us, we do Z, ZZ, that gives us AAA, perfect. Okay, let's try the check 50 here. All right, if you think we're going to pass check 50, guys, give us a 0 for no, a 1 for yes in chat. 0 for false, we're going to fail check 50. 1 for we're going to pass check 50. Are we missing any other? I mean, we might be missing some additional checks, like these different little off checks that it likes to put in here. Got a couple of ones. Every people believe in me. Thank you. No. Oh, a lack of argv. Oh, so close. Handles a lack of argv1. So if it doesn't equal 2, print this. If the arg count does not equal 2, do this. Hmm. So why would we need... Why would we need some sort of... I mean, it's trying to do this conversion here, right? Segmentation fault core dumped is trying to do this conversion on key if there's none given. So instead we'll put this here. Get rid of this. There. But we're using key here. there, and we'll move it out. So we'll do the check of the function here. Yeah, exactly, low. So we moved it down here, and instead of having key be here, we do that. Dang it. Like that. But we wouldn't even need this at all. Cool. Now that should work. All right, here we go. Zeros and ones, guys. Come on. Bring me home for the weekend. Bring me into the weekend. Come on. Come on. Woo! Yes. All right, you guys. Oh my goodness. That was Caesar cipher. Holy cow, that was a problem. Man, like I really feel for those Harvard students. Like if this is like your first time ever programming, like I can see why this would take someone like a week or 2 weeks or 3 weeks to do. Like they have a lot of concepts that they have to learn about. Like they have to, all these declarations of variables, what like returns are, all these functions, how to make functions. Like if you had never seen programming, like yeah, I can this would definitely take I can see how it takes people a few weeks to complete this. Yeah. Now I did complete it in less than 3 hours here. I was hoping to complete it in less than an hour and a half, but I didn't realize how lengthy the amount of requirements was. I thought it was going to be fairly straightforward with just maybe calculating a cipher, right? Just doing the cipher portion, but it had us do all these. I didn't realize there was like an argv problem as well, and so I didn't. We had to implement that and stuff. So and I wasn't familiar with that in C. And now if it was Python, we could have probably written it up pretty quick. Um, but yeah, but I am pretty happy that we were able to do this in under 3 hours. But I can definitely see how this would, do not be discouraged at all if you're a beginner programmer. This is your first couple of weeks or months, and this would, take you a few, sessions to complete of sitting down, trying some stuff over and over again. This was not like a very very I mean it was simple, but it just based on the actual, it just was a lot. Yeah, thank you so much, Ryan and SS Low. You guys are awesome. Thank you so much for joining me today and helping me out. Jaws, thank you. Diane Williams, thank you so much. Um, who else we got here? Janice, thank you. Insomniac, But big shout out to Ryan and SS Low for joining me today. You guys were huge in in helping me when I got stuck and giving me a little bit of pointers and just helping me with the general syntax. That's mainly the overall concepts. I can get there, but what really slows me down, I think what dragged out this process from just an hour and a half to 3 hours wasn't the actual problem itself, but was just the syntax, right? Of trying to continually having to just go back and make changes to my, you know, declarations of types and all that. That just added a couple minutes, and over time, it increased this process. But we're learning. It's okay. I'm willing to put in the hours now and really grind away to be successful in the future at this and set myself up now with this foundation. I had some people reach out to me with, how to, build programs and or build, similar projects and start projects to how I've kind of been doing it. And I didn't, shoot, I didn't give that advice today like I said I would. Hopefully, who was that asked for that advice? Um, his name is in the Discord. It's just S dot dot dot. I think it was Sam. Was his original name in the Discord at one point? But if you're in here, S dot dot dot, please let me know and we can talk about that really quick before I sign off. I'm stuck on the next problem set. No shame in my game. I've even looked at the answer and it just isn't clicking. Not gonna lie, I watched you work it out. It's impressive. I'm working on developing a similar thought process and approach to problem solving. Yeah, so I will say, Ryan, I don't want to people to get like discouraged that I do solve these problems. I have been putting in quite a lot of hours and just and I like in my DSA book alone, we've solved over 100 practice problems just out of this book alone. And then in Python Crash Course, I solved a bunch of practice problems. So all of these problems are just compounding, and I'm getting familiar with these techniques now. Definitely talking with you guys helps a lot. If it was just me by myself, now it would be a different story, but I'm talking through things aloud. I'm really now my debugging needs to get better. That's my last resort when it should be my first resort is to debug with like print statements and stuff. I will say that I need to get better at that for sure. But yeah, is really is dot s dot dot in here in the from the Discord. He asked me, or they asked me, to just give a quick rundown about how I start my projects in Python. Um, and I wanted to try to answer that for him, or for them, rather. There we go. What percentage is my mouse at now? 19? Not too great. Not too great. Right. Cool. All right, you guys. I'll go ahead and reach out to S dot dot dot. I think the S dot dot is because Discord is in streamer mode. Oh, that would make sense if it is trying to hide names. No, but it shows me other people's names, so maybe he just changed his. Oh no, but some of them are also dot dot dot. So it looks like maybe some people have streamer mode like enabled or disabled on their end. Okay. Um, I'll have to reach out to him independently. Looks like he's not here. Um, but anyways, tomorrow, you guys. So tomorrow I'll be streaming. I don't know exactly what time, but I'll send out an announcement in my Discord. For those that are new here, I have a Discord link below where I compile all my study resources, announce my streams, and also provide input from various other people, network. It's a really great place to be. Um, so tomorrow we'll be going over the last problem in the problem set 2, which is substitution. We'll be doing this one. And so we'll tackle that, and then hopefully on Sunday we can watch the actual week 3 lecture and get into that. But tomorrow I might do a double feature stream of doing a first session of solving the substitution problem, and then a second stream of just me doing live work on my project, the small business manager, or maybe reading some data structures and algorithms and doing some neat code. Um, just to help kind of shake things up. We've been doing this for the past 2 days, so I did want to kind of shake things up in case people were waiting for some other content and not CS50X. But thank you so much for joining me this evening, guys. We're getting really close to 1,000 subscribers. I really, really appreciate all the support you guys give me in the streams and in the Discord. It really helps me to keep going. And yeah, Ryan, work on it with me live. We'll do it together. That sounds like a great idea. Come back tomorrow and we'll do it live together. That'll be fun. We can brainstorm stuff. And then maybe that can help you also, talk through working through the problem out loud with me, and that can help you with your week 3 one. Yeah, so we'll be back tomorrow for a potential double feature where we'll do CS50X, the last problem substitution for week 2, and then we'll do for the second stream, just do a coding session, a neat code session like we usually do hanging out. But yeah, sorry if I wasn't super active into the chats today. We were just kind of solving this, and I was really using a lot of brain power to analyze this and figure it out. It was really good, practice. I will say that C syntax has really gotten me to think about, data structures a lot more. I've had a lot of instances where I've been reading and programming through C, and I've related things back to this book that we read, and I can kind of relate to see how Python actually kind of made these things up with using C, right? Because that's where it's based in. So it's really kind of cool that these pieces are starting to come together here for us. I can see why C is kind of used as an introductory language, because it really is that backbone of from programming and being able to really do a lot with it. And so and it gives you that practice with understanding all those data types and how to manipulate them, the ASCII table. Like this is all new to me as well. So anyways, sorry for rambling. I'm done here, you guys. I'll be back tomorrow. Thanks so much for joining me. We streamed for 3 hours tonight, so a really successful Friday stream. Thanks for sticking with me. Thanks for following along. We're coming up on 1,000, which is crazy. I'll see you guys tomorrow.